So we've heard about CGN sucks. We've heard about this for a while now, right? We've certainly kind of beat the drum that we need to deploy V6. V6 is the solution to not having to deploy CGN. But we all know that that isn't actually the case. It is the case to some extent, but we're going to need a bridging technology, right? So CGN is the bridging technology. And so we should talk about how we actually can deploy it and what effective methods are. So talk a little bit about how Rogers is working on that right now.
I almost feel dirty talking about this now after Lee Howard talked about V6. But anyway, on we go. Bit of an introduction. So there's kind of two things that we looked at, or when we looked at this issue generically. One was there are going to be some folks that, for whatever reason, have decided they want to get it, they're going to look at CGNet. How do I deploy it? How do I actually put it into a network? There's a lot of operators out there, particularly mobile, that have been doing this, or at least translation, maybe not formal carrier-grade NATs, they've been maybe using enterprise-level translators, et cetera. But they've been doing translation for many, many years now. And as their customer base starts to actually use internet services, they have smartphones, et cetera, and that starts to proliferate, they're doing a lot of this moving forward. Now, this presentation is not about, why you should do carrier-grade NAT. It's if you decide to do it for whatever reason, what are some of the integration techniques or what are the things you can do to try to get this to actually work correctly. Now, it's a bit of a level set, as I had mentioned. This is not about it's good, it's bad. In fact, I actually don't really like NAT per se. I'm actually one of the V6 guys back home, but I'm also responsible to make stuff work, so off we go and how do you make this work when required. What I found is there's a lot of discussion about is it good, is it bad, but there's not a lot of discussion out there in terms of how do you make it work when you decide you need to do it. Or even if you have translation services in your network, is there any way to make it work better, i.e. the mobile space? The other item too is if you have a running network with native v4 running for most of your customers, you want to add in carrier-grade NAT. How do you do that without impacting your customer base to the best extent possible? Because what you don't want to do is add a carrier-grade NAT technology to your network and then disrupt your ongoing customer base and make their service worse for any reason. At least that's not a good decision, I would think, from an operator standpoint. And then look at it from a practical and pragmatic approach. How do you do architecture around carrier-grade NAT, or how do you add it in? Another thing to look at is, like I mentioned earlier, most mobile networks already do translation for most customers. I mean, there's a little bit of public addresses assigned to some endpoints, but for the most part, it's all translated. And that's growing pretty fast. Not all wireline networks are going to have enough v4 addresses before they can get everyone onto v6 only. So they're going to have to, as mentioned, do some type of bridge. And by the way, none of this replaces your enthusiasm to try to deploy v6, get it working, and move to it as fast as possible. This is by no means a replacement for a v6 strategy. This is what you do as a bridging technology or bridging capability for v4. The other thing that I'm not addressing here is some of the business issues related around translation. This doesn't fix, or nothing I'm going to present fixes the problems with translation. So if you have to identify customers for certain types of service access, et cetera, this is not talking about that. This is about how could you get translation to work in your network effectively, or one version of it. Now, when we looked at this and we said, okay, what are the high-level considerations for adding carrier-grade NAT? Some of the things we looked at is, well, how do we minimize impact to our running state native v4 customer base? Seems pretty self-evident we'd want that. Another item we looked at is, can we come up with a flexible model where we can change things over time without unduly impacting our operations and injuring folks? Try not to make them go through more effort than required. And can it scale based on the changes of our carrier-grade NAT demand over time? And what we found, as one of the pictures shown on the slide there, is that might mean that your carrier-grade NAT resources change positioning of your network from a more centralized to a more distributed position over time. As demand goes, you might want to scale that out. Subscribers on traditional v4 services normally require direct, or as direct as you can, connectivity to the internet. So for most of our customers today, at least on the wireline side, you want to get them to the internet as fast as possible. The good news is that's good from a performance perspective for them. The good news for us is also cheaper, right? You have fewer links to upgrade and a little less network to have to pass them through. The issue with carrier NAT customers is their next hop is not the internet, or their next point of reference in the network is not the internet. It's actually to get to a translator. So a fundamentally different path you want them to go than the rest of your customers that could particularly already exist. So the question is, how do we deal with this coexistence? How do we get both, these carrier-grade NAT customers added in, if that's what you're doing, and how do you not impact your mainline customers? So, the question here is, in terms of from a solution perspective, is CGN placement becomes a big issue. Is you don't want to overspend yourself in the beginning, saying I need to distribute carrier-grade NAT for the future. So you might want to change where you place your carrier-grade NAT resources over time. And that might actually change. So in the arbitrary topology you see there, between where I might have some peering and where I have my access routers, that position might change to be more efficient and be able to be distributed to take on the additional load. The other component we were looking at would, how do you try to keep the configuration and the complexity of the environment as low as possible throughout this? Now, it seems a bit utopian that, I want a lot of flexibility, but I want a lot of control over the complexity and amount of changes I have to go through within my network. So it does sound utopian, but we think we found a reasonable middle ground there. And as mentioned earlier, how do you get that? Going back to the placement over time, we found that the optimal placement of carrier-grade NAT, I'm not doing that well today, resources throughout the network is going to likely have to change to be optimal. Now, a particular issue that we had, which not everyone else has, is we kind of see the world as both a wireless and a wireline world. We have both. And so they both grew up from two very different places. So wireless is pretty much all translated for most people, not just us. And wireline is there's pretty much no translation right from the onset. So the question is, how do you come up with an architecture or a way of doing something where you can apply the same methodologies to both, and then if this is your problem space, converge them later on. Now, obviously, if you're only a wireline provider, you're not converging much. And if you're only a wireless provider, you may not be converging much. But a lot of people out there, or there might be some partnerships that come into play later on. So you might want to think about that. Now, the other thing that we looked at from a solution requirement was, how do you do CGN bypass? Because you have a lot of services within your network that you may not want to translate before you get to your own service, at least. Because you have an opportunity to kind of avoid that problem. So to avoid that issue, we want to save costs. We don't want to buy translation services for things we don't have to buy it for. So how do we get a bypass technique working? That was one of the mandates from a solution that we need to look at. So on to what we looked at actually doing. So that was kind of set the stage of what we were thinking, why we were driving down this path. By the way, this does not replace V6 strategies. So what we decided to do was leverage MPLS VPNs, as defined in RFC 4364. The reason why we looked at this was it's well deployed. I mean, we have a lot of experience with MPLS VPNs. We've been using them for a number of years, traditionally for business services. So our operations folks know how to deal with it. Our engineering folks know how to deal with it. We know how to design and architect around it. So we thought that seemed like a pretty good idea. And just to pause there, when we first had vendors coming to us wanting to sell us equipment, of course, they were giving us all kinds of crazy techniques as to how to make carrier-grade NAT work, policy-based routing, et cetera, et cetera, et cetera. And we're like, well, this is pretty complex. We don't do much of this today, and we don't want to add in all this additional complexity. Hence, back to what do we already do, and how do we leverage technologies we already have to do translation? And the other thing about MPLS VPNs was it allows us to overlay this onto an existing network without actually changing the underlying topology and the services that already exist within our network. We can add this in on top and not affect anything underneath. That was one of the major advantages to doing this. So to kind of put a little bit of pictures in here, the way we looked at it is we can loosely define CGN zones, groups of customers that need to be translated to get to the internet. And we threw them into VRFs on endpoints and then used LSPs to kind of get them over to wherever the translator was. Now, the location of the PE in this particular case in the translator is irrelevant to the topology. That can exist literally anywhere, and that's pretty dynamic. If you happen to be using LDP in your network, it just, you figure out your other endpoint, it just kind of works, and if you move that translation endpoint, well, just magically, LSP magically moves over somewhere else. Not magically, it dynamically moves over. And regular customers wouldn't even see any of this. Pre-translated traffic is inside the VPN. Post-translated traffic is in our particular case, in the global routing table, or the same routing table where all our traditional internet customers are. Now, from a CGN bypass perspective, it was actually pretty easy to make this work within this model. Effectively, if you put your services into a services VRF, all you basically do is import-export statements or extranet your own services to your customer base. So what that effectively does is it means that your services are not translated to your own customers, whether that be your DNS server or something very basic or other services you might have. And this is all within the standard MPLS VPN model. And again, normal customers don't see any of this, and for your traditional customer base, it's irrelevant that this is all operating over on top. Another good thing about here is there was no traditional traffic engineering required to do this. It just worked pretty fluidly, and it worked pretty well. Another look at this is you can then join that same set of services to as many of the CGN zones as you want. So if you have multiple CGN zones because you want to be able to segment your customer base over time, to be able to scale that in the future and put them towards different translation resources, you can basically extranet the same set of services to each one of those zones as you please. And each one of those translation zones will go to their relative translator to get to the internet, or they will go to the directly to the services for their various services. The other interesting thing here is this doesn't have to just be for internal services. You can extend this to business partners and other folks who can be placed into that same zone. I mean, the servers in that zone can have public IPs, and they can be exposed directly to your global table. So you can feed content into those zones as you want, and effectively you can then stream that out to the customers. Obviously, anything in there has to be aware that you're going to potentially see private addresses, or there's the shared address space range, the 100.64 range. So you have to be aware that that gear is operating in this environment. But as long as the equipment's aware or the software is aware, it works pretty fluidly. From a dual stack perspective, obviously we looked at how do we add this into a dual stack option in terms of being able to give someone V4 and V6, and that also worked out in our favor. We have two methods that we were able to do this with. One was we could land the V4 and V6 connectivity into different VRFs. One could be the global table, and so the V6 travels just like any other traditional traffic would flow, and your carrier grade NAT traffic or your V4 connection lands into a VRF that goes off into a translator, and those are managed separately. Another way of doing it is on the source side or on the access side, you could just leak those routes into the table, and it just becomes IPs available at that access router. So that worked pretty well. So from a dual stack perspective, you can make this work. So there's nothing inhibiting you from then incrementally going to add V6 in for this customer. And then in the future, you can just turn off the V4 piece if that customer becomes V6 only. The other piece that worked really, really well was our view of the world is we had to make this converge between our wireless and wireline properties. So the nice thing about this architecture was we could basically ignore all the complexities of what goes on our mobile network and effectively just attach those VRFs or VPNs from our mobile network, attach them to our larger network, and use the same common translation infrastructure for both wireless and wireline. So effectively, it's a common way of providing a service that acts differently between both. And again, because we're using different CGN zones, which are represented by different VRFs and VPNs, we can segment that or converge those at different parts throughout the growth cycle as we see fit. The mapping of a given translator or translators to n number of CGN zones can change very dynamically. All you're doing is effectively, for those who do this configuration themselves, you're just changing import-export statements on edge boxes, and you're pretty much done. There's very little configuration both of the carrier grade NAT side and the rest of the configuration on the access side that needs to change to do all that remapping. It also helps, fix a lot of challenges because there are a lot of problems with translation, logging, and a lot of other things potentially have to occur, and so that can happen pretty fluidly as well. And you can offer the same set of services, whether or not they're wireless or wireline customers or where they're coming from. When we're looking at other considerations, so this goes back to why we kind of looked at the MPLS VPN option versus some of the other options. I mean, we did look at policy-based routing, and we found that would be really, really ugly. I mean, we could have said, based on your source address, go this way, and, for everything else, go the other way. We found that it's a lot of change. We don't want engineers and ops people like literally tapping away at keyboards, changing configuration all the time, because that normally translates into problems. The fewer times you have to have someone actually change configuration on a box, the better for us it is. It typically works out. The other item we looked at was MPLS to E. We thought, well, we could traffic engineer this traffic over from one location to the other, but that's a lot of overhead. That's a lot of work that we would have to add into the network for something that we didn't want to spend a lot of time on at the end of the day. One of the original goals is how do we use technologies we already have, that we already operate, that we already know well, that don't require a lot of ongoing maintenance, but provide a lot of flexibility. So traffic engineering, yeah, it would work, it could have worked, but we found that it was just way too much complexity to put into something that will live and hopefully die in the not too distant future. And there's other things that we looked at in terms of multiple topologies and putting in all kinds of crazy techniques to kind of separate our customers. But we found that the other options, again, a lot of time, a lot of cost for a service that, again, it's not really worth spending too much time on if you can avoid. The less time we spent on this for us was the better. We wanted to spend our time on other things like B6. From a general experience perspective, it works pretty well. Now, it's not our experience. We've spoken with others that have both used it based on our input. We have a draft out in the ITF that describes this model. Some others happen to come to a similar conclusion. And the feedback we received is that from adding in our carrier grade NAT, this architecture works pretty well. I mean, it works pretty fluidly. It's reasonably easy to deploy if you already have experience with MPLS VPNs. If you don't have experience with it, it might be a large bat to use to get this working. So I don't necessarily advocate this option if you have no experience with that, but if you do, it's actually it's pretty easy to add it in because you're already familiar with all the techniques. It actually didn't have a huge initial cost because there was no changes to the actual access network that we had to put in. The only costs that were borne at the end of the day were the cost of the actual translator. So those are costly, and in the future, if you have to add IPs on your global pools, that will cost money. But from an infrastructural perspective, there wasn't a lot of cost. Most of the capabilities that are used are already inherent in most of the access nodes and the various other components within the network, at least the network we have. And we have generic routers and switches, as most of you will have. From the mobile side, it works there as well. We were able to bridge us into the LT HSPA environment pretty well. Your P gateway GGSNs have the ability to take APNs and attach them to VRFs, and we can attach different APNs to different VRFs as we want. So we have a lot of flexibility there. So this worked both in a DOCSIS cable world. It also worked in a DSL world, and we had this work on the mobile side. So it kind of worked across all the various access technologies that we needed to work across. And it separated traffic well, and what we found was our traditional customers flowed nicely to the internet as they did before, and for those few that need to use this, and in the mobile case, the most of them that had to use this, it worked. They went to a translator, and we were able to segment that as necessary. Now, one thing I didn't go through too much within this deck, but when we had a larger set of requirements that we had looked at originally when we looked at translation. So we looked at, do you want centralized versus decentralized location of translators? So the answer is, well, we said we wanted both. We wanted to be able to move it around, and the answer was yes, we could do that with this architecture. We wanted to be able to say, can you coexist with traditional IPv services without impacting them? And the answer was yes, we could do this, and it doesn't impact your underlying customer base. The other thing we looked at is, can you do CGN bypass? And the answer was yes, we could do this, and you could bypass CGNs pretty easily. It's all within the MPLS VPN framework. Another thing we looked at is routing traffic. Can we do traffic control with this? And it's, yeah, we can. We're sending our translation traffic in one direction and our rest of our customers in another direction. The other thing we look at is, well, do we have flexibility? Can we split our translation zones as the actual demand grows and then contracts later on? The answer is yes. We can remap the number of translators to the number of CGN zones very easily throughout the life cycle of carrier grade NAT. The other thing we looked at is it's supported well within both the wireless and wireline properties, and the answer was yes. It's technologies that are available in all our access gear that we already have today. There's nothing magical about doing this if you're a traditional operator that operates MPLS VPNs. Another thing to look at, can we work with overlapping address ranges? And the answer is yes. If we don't have enough private address space or enough shared address space, you can just overlap between the VPNs. So the answer is each VPN could have the same address range if you wanted to. The caveat there is if you're extranetting services into those CGN zones, you now have to have instances of those services because you can't have literally the same server talking to the same IP in multiple VPNs. So there's a caveat there. So you can do overlapping address ranges, but then there's a service impact of doing that. But it does work if all you care about is getting customers translated to go to the internet. Does it work with a dual stack operation? Well, the answer is yes, we can make this work with dual stack operation. So it doesn't inhibit us from adding V6 in as time goes on for those customers. And does it help out with the logistics of what do you have to do when you add in something like carrier grade NAT? And the answer is yes, logging, connection management, that can all be done. And the nice thing is it can be done in a standard fashion, and we don't have to have different deployments for our different kind of properties. We can kind of have a common deployment for both our wireless and wireline networks, and it works pretty fluidly across both. So based on the fact we were over time, I kind of try to concatenate that bit and leave a little time for some questions. So that was the end of my slides. I guess at this point, talking pretty fast, was there any questions to us? Again, I feel kind of dirty talking about carrier grade NAT, but did anyway. Lee?
Lee Howard, Time Warner Cable. Is this architecture based on operational experience, let's say? Do you get my question?
So you're saying, is the architecture of how we used MPLS VPNs based on operational experience or how we're doing translation?
Let me ask the pointed question. Did you just say you're doing CGN?
Well, on the mobile side, it's always been CGN.
Right.
Well, sorry, it's always been translated. Traditional translation occurred.
It might not have been carrier grade.
Correct. Well, I mean, you use what you had 10 years ago, right?
Any other questions? Okay, thanks.
Okay.